There are places inside the universe where light should never reach, areas so remote, so ancient, that even time itself seems to break down. But the James Webb Space Telescope wasn't built to study what's easy. It was designed to see what no other human tool ever could. Gosh, and when it opened its golden eyes to the cosmos, what it found didn't just marvel astronomers, it unnerved them. It wasn't the beauty of galaxies or the clarity of distant stars. It was the pattern, or more precisely, the break in the pattern. What Webb began to uncover, layer by layer, photon by photon, was a universe that doesn't match our equations. It was as though the cosmos was playing a different game all along. Galaxies formed too fast, structures to advance appeared too early, and the very laws that governed expansion, time, and matter began to unravel under the scrutiny of Webb's infrared vision. The deeper it looked, the more reality fell apart, until, one by one, scientists began to whisper a terrifying thought. What if everything we've been taught about the origin of the universe is wrong? The first wave of discovery struck like thunder across the astrophysical world. James Webb wasn't just seeing deeper into space. It was seeing further back in time than any other tool ever had, according to our current model of the Big Bang. The early universe should have been a chaotic fog of scattered particles, slowly coalescing into the first primitive galaxies. It should have been messy, uneven, and sparsely populated. But instead, Webb revealed massive, mature galaxies, some larger and more organized than our own Milky Way, already formed just 300 to 400 million years after the supposed beginning of time. These were not infant structures. They showed shape, complexity, even signs of star generations that shouldn't have had time to exist. It was like digging into the foundations of a skyscraper and finding an ancient, entire city built long before the first brick was supposed to be laid. One galaxy in particular, CEERS 93316, has a redshift so extreme it suggests it existed at a time when, by our models, galaxies shouldn't exist at all. And yet, there it is, spinning, glowing, built. This has left astrophysicists scrambling because if galaxies were already well evolved so early, then the timeline of the universe's expansion, cooling, and evolution doesn't just need adjustment. It needs reinvention. And the terrifying question remains, how did the universe build so fast? Or worse, what if it didn't build at all, but was simply there, waiting to be discovered? The James Webb images didn't stop at surprising galaxies. They began to show something far more disturbing, an architectural flaw in the very fabric of our universe. In theory, cosmic structure emerges gradually. Particles form atoms. Atoms form gas clouds. Clouds form stars. And stars gather into galaxies over billions of years. Those galaxies pull together into clusters, filaments, and webs that span the observable cosmos. But Webb has started detecting hyperstructures, massive galactic webs, and connections far in advance of what should be physically possible. These are not accidents of light or observational noise. They are measurable, traceable, and consistent across deep fields. And the mathematics doesn't hold up. According to Dr. G. Illingworth, one of the astronomers working with Webb data, we're seeing structures that require twice the time the universe has had to form, which implies either our model of gravitational growth is wrong or something unnatural is guiding the assembly. Dark matter, the invisible scaffolding meant to explain these structures, has failed to appear where expected. And if these connections formed without dark matter's help, then perhaps dark matter itself was never real or was something entirely misunderstood. Some physicists are even proposing that gravity itself might behave differently in the early universe, that the laws we follow now are just local laws, not cosmic constants. And if that's true, then the universe isn't a static framework. It's a living system with regions that play by different rules for years. Scientists have wrestled with a paradox called the Hubble tension, a growing disagreement between how fast the universe is expanding now versus how fast it should have been expanding in the past. Webb was supposed to resolve this. Instead, it made the problem exponentially worse. When measuring the early universe, scientists used relics like the cosmic microwave background, an ancient glow from the Big Bang. But when Webb looked at later, indicators like redshifted supernova and galaxies, the numbers didn't match. The early universe says we're expanding at one speed. The modern universe says it's faster too fast. And Webb's data confirms both sides with fantastic precision, making the contradiction plain. Some scientists are now describing this not as attention, but a crisis, a sign that our entire model of spacetime expansion might be mistaken. What if the universe isn't expanding uniformly? What if different sectors of space are stretching at different rates? Or worse, what if we aren't even in the same frame of reference anymore? The implications go beyond math. They touch on the possibility of multiple layers of reality, shifting dimensions, or even a second inflation event that no one predicted. And that means the cosmos may not be the open book we thought, but a puzzle with pieces missing, scattered beyond what our senses can reach for decades. We've believed the cosmic microwave background was the ultimate proof of the Big Bang, a fingerprint from the first light that ever escaped into the universe. But now, data from James Webb shows something deeply unsettling, that this first light might not have been first at all. In fact, Webb's high-resolution analysis of distant galaxies reveals that young, dense star clusters burning hot and packed closely together can produce infrared radiation so intense and so broadly redshifted that it mimics the very signature we once attributed to the beginning of the cosmos. This means the so-called background may not be a clean echo of the origin. It may be layered noise, the accumulated light of early galaxies bleeding across the timeline, distorting our perception of what came first. If this is true, the entire chronology of the universe falls into question. The Big Bang might not be a singular event at all, but rather a transition, a change in state, or even the aftermath of something older. And that possibility terrifies scientists because it means we didn't discover the beginning. We uncovered a veil. And behind that veil may lie something so ancient, so alien to our understanding, that no equation, no simulation, no law of physics has prepared us to face it. One of the most disturbing revelations came not from a single object, but from a pattern hidden across Webb's deep field observations. When the data was layered, filtered, and analyzed with AI-driven recognition systems, researchers began to encounter symmetries in galaxy distributions arrangements that were too organized, too evenly spaced to be the product of random cosmic evolution. These weren't. They resembled resonance systems, as though space itself had harmonics. Entire clusters of galaxies, separated by billions of light years, reflected geometric properties, angles, arcs, durations so precise that some astrophysicists have quietly begun to describe the universe as exhibiting crystalline behavior. This shatters the core assumption that large-scale structure is emergent from chaos. Instead, it hints at a governing pattern, a scaffolding laid out not by blind gravity, but by some unknown rule embedded within the cosmos rule we didn't write. If this symmetry is real, it raises a question darker than any. Are we living in a naturally evolved universe or in one that was constructed? In a recent Webb survey of gravitational lensing phenomena, scientists found something that shook the foundations of observational astronomy: a repeating signal. While observing a specific lensed galaxy system, the Webb recorded nearly identical fluctuations in brightness occurring at irregular but statistically impossible intervals. At first, this was believed to be a data glitch. But after triple-checking instruments and running simulations, the team concluded it wasn't noise, it was a repetition. Somehow, the same cosmic structure, separated by billions of years and billions of light years, was mirrored across space. This suggests that light itself may be caught in a loop, bending not just around matter, but through a deeper topology of space that we've never mapped. If this is the case, then our notion of the cosmos as a vast open sea might be entirely wrong. We may be trapped inside a curved, holographic membrane where light folds back on itself and everything we see is both real and repeated. Like watching a reflection, unaware that you're inside the mirror. Not every mystery Webb uncovered was noisy. One of the most chilling came from what it didn't detect. While scanning a region of deep space between massive galaxy clusters, Webb recorded an eerie void, of vast, silent patch of sky without infrared light, radio waves, or any electromagnetic activity whatsoever. This isn't unusual. Cosmic voids exist, but this one was different. Its edges were too sharp. Its temperature drop was too uniform. Within it, quantum particle detectors aboard adjacent probes recorded an unusual absence of virtual particle interactions, clean space in the quantum foam. Some physicists have proposed this may be evidence of a quantum scar, an area where the laws of physics broke down or reset after some impossible event. Others go further, speculating that this is a cosmic firewall, a region where information is destroyed or censored from our view. But perhaps the most terrifying theory is also the simplest. This patch of space is dead, not quiet. Not empty, but erased. Like a phase of reality that was intentionally removed and isn't meant to be looked at. Perhaps the most metaphysical and disturbing implication of James Webb's discoveries has come not from any single observation, but from the cumulative pattern they create. Scientists began noticing that the more we observed certain regions of space, the less stable our models became. The equations that previously described galaxy behavior started deviating. Physical constants showed tiny but measurable drifts in predictions. In several papers quietly circulating among top theoretical physicists, the term cosmic observer effect has begun to appear. The idea that the act of observing the universe at such deep fundamental levels may be altering it. That space-time at its core may be reactive, not passive. Our tools, like Webb, are not just uncovering secrets. They're changing them in the process. It's a theory long considered fringe, but now, with Webb pushing the limits of the observable and collapsing the consistency of long-held models, some wonder if the universe has thresholds not of size or energy, but of permission. Perhaps we've just crossed one. The James Webb Space Telescope was built to reveal the unknown. But maybe it revealed too much. What began as a mission to study the earliest galaxies became a confrontation with something far more profound, a universe that isn't just more complex than we imagined, but perhaps more aware. Our models are collapsing. Our constants are not constant. Galaxies are out of place. Time bends where it shouldn't. Light itself is behaving as if it knows we're watching. We thought the Big Bang was the start. But what if it was just a reset, a ripple in a much older ocean? What if that ocean, this universe, reacts when we get too close to understanding it, not out of hostility, but as if it's protecting something, like an organism guarding its core or a simulation shielding its code? The greatest minds of our time now stand at the edge of this abyss. For the first time, they're not asking, what is out there? They're asking, should we be looking at all? Because the more we stare into the void, the more it feels like something is staring back. We set out to study the cosmos, but now the cosmos has noticed us. What do you think James Webb truly uncovered? Are we rewriting the laws of physics or peeling back a layer of something we were never meant to see? Let us know what you believe in the comments. If this shook your view of the universe, share it, because the world deserves to know that the questions we're asking now are far more terrifying than the answers we once believed. Subscribe, turn on notifications, and stay curious, because this is no longer about galaxies, time, or even science. This is about reality itself, and it's starting to unravel.